So good morning, I'm Kiran Kumar V, working in Assam Department of ISC. So today's topic we'll see an advantages and disadvantages of divide and conquer, and we will go for a decrease and conquer approach, and also there we'll see one algorithm, that is a topological ordering or topological sorting. Okay, now advantages and disadvantages. That is, advantages of divide and conquer is there is a parallelism. Okay, where simultaneously you can sort the left hand side part, right hand side part, such that at the combined time the data will be visible. Next, the cache performance. When the sub problem fits in a cache, so if that particular value or if that particular function is needed all over again, that can be fetched, that can be used. It allows solving difficult and often impossible looking problem like tower of an eye also can be solved using a divide and conquer technique. Next, recursion is slow. Okay, it is complicated. It has become then a basic iterative approach. The same sub problem can occur many times, so it is solved again and again. Okay, so these are the three advantages and one disadvantages of the divide and conquer. Next comes the decrease and conquer, where there are three major variation of decrease and conquer, where if there were decrease by a constant, that is example for that is insertion sort, decrease by a constant factor, that is a binary search, and a variable size decrease, Euclid's algorithm. Now a topological, next we will come for an algorithm, topological sorting, which is an algorithm under decrease and conquer. Now, a graph and a digraph. A graph is a normal graph which consists of an vertices and an edges. A digraph is nothing but a directed graph. Now, what are the ways in which you can represent a graph? Using an adjacency matrix or using an adjacency list. Now, here what you're going to find here is digraph, and this is a DFS forest of the digraph for the DFS traversal started at A. So all this DFS you have studied in your third semester. Next, what is a digraph? It's a directed cycle in a digraph. It's a sequence of three or more of its vertices that starts and ends at the same vertex. If ABA is a cycle, okay, then that will be a directed cyclic graph. Okay, whereas here for the directed for the digraph, in order to apply the topological sort, here it should be a directed acyclic graph. There shouldn't be any cycle. Okay, there shouldn't be any cycle here in terms of a DAG. Okay, now what is the mode? Okay, now what is the motivation? Consider a set of 5 required courses C1, C2, C3, C4, C5. Okay, where a part-time student has to take some degree program. The courses can be taken in any order as long as the following course prerequisites are met. C1 and C2 has no prerequisites. C3 requires a C1 and C2, whereas C4 requires C3 and C5 requires C3. So student can take only one course per term. In which order should the student take the course? So this problem is nothing but a topological sorting. Okay, now topological sorting, to be possible, a digraph should be there, that is it should be a directed acyclic graph. Okay, where there are two efficient algorithms, that whether a digraph is a DAG and if it produces an ordering of a vertex, that solves the topological sorting problem. The first one is based on DFS, the second is a direct application of decrease by one technique. Okay, now in terms of DFS, what you're going to do, you're going to perform a DFS traversal, note the order in which vertices become the dead end. Next, you're going to reverse this order, which yields a solution to topological sorting problem, provided no baggage has been encountered during the traversal. If a baggage has been encountered, the digraph is not a DAG. Okay, that is, there shouldn't be any cycle. Okay, now in this case, see here you have C1 and C2. Now look for a incoming edge which doesn't have, look for a vertex which doesn't have an incoming edge, C1 and C2. Okay, now what you're going to do, C1 you add it onto the stack. Okay, C1 you add into the stack, and then C2 also you're going to add into the stack. Next what, find out which is the adjacent of C1 or which is adjacent of C2. You find C3. Yes, C3. Next you find any adjacent to C3. Yes, C4 and C5. But here we'll move to C4. Okay. Next we'll move to a C5. Now C5 any adjacent vertices? No. Pop that. Next C4 any adjacent vertex? No. C3 any adjacent vertex? No. C1 any adjacent vertex? No. Then C2 any adjacent vertex? No. Okay, either you can consider C1 or C2, and note that any graph can contain many more than one topological ordering. Okay, so it is like C1. Okay, on reversing it, C2. Okay, C2, C1, C3, C4, and C5. This is the topological ordering. Okay, next this is nothing but a decrease and conquer technique. That is, here it is nothing but what you call it as a source removal method or decrease by one conquer technique. Okay, repeatedly what you are going to do, repeatedly we are going to identify a remaining digraph in which does not contain an incoming edge, and we go on deleting that and all the edges from that particular node. Okay, we go on deleting. The order in which the vertices are deleted yields the solution to the topological sorting problem. Okay, now this. So you're going to delete C1. Here this is with respect to a what? It is also called as source removal method or using decrease by one and conquer technique. Delete C1. Okay, now C1 will be deleted. Now select the node which has no incoming edge, C2. Next, which has no incoming edge, C3. Next, that has got incoming edge, C4, followed by C5. So this is the order. As I told you, one graph can have any number of topological ordering or sorting. Okay, next, application. Topological sorting may have many alternate solutions. So this is for scheduling in a program compilation, cell evaluation, ordering in spreadsheet formulas, topological sorting, cell evaluation. Next, resolving symbol dependencies, linkers. So this comes in system software, which you are going to study in your 5th module. Next, the summary. The summary, here we have studied a divide and conquer. Okay, we have studied all this algorithm and advantages and decrease and conquer approach. Okay, we studied topological ordering. Okay, thank you.